Okay. All right, so 8e, let's do 8e. It says determine the exact value of each of the trigonometric expressions. So this is 8e. I do have a unit circle over here, so we can look at that in a bit. So cosecant of pi over 12. So there's a few things going on here, I guess. We don't have identities for the reciprocal functions, do we? But we do know that cosecant is actually 1 over, what, sine? Okay, so this is 1 over sine of pi over 12, I guess, right? So what we're going to do, I'm going to change that color. So what we're going to do is we're going to try and work on the sine of pi over 12, okay? So sine of pi over 12, now, given this section, sum, difference, identities, can we write pi over 12 as a sum or as a difference? And that's going to be your key there. Now, a sum, it's tough to add up to 1 over 12. We don't have a lot of things on the unit circle, but we do have some things on the unit circle that will subtract to get pi over 12. So if you think about 1 pi over 12, right, 1 pi over 12, that could come from, you know, let's say if we have 2 over 12s, that could come from 7 minus 6 pi, right, pi's, or it could come from 5 minus 4, so on, could come from 4 minus 3, which I'll probably pause there. So do we have a 4 over 12 or 4 pi over 12 on our unit circle?
Yes.
That's actually 1 over 3? Okay, so that's pi over 3. Hey, that's awesome. What about 3 over 12? That's actually pi over 4. So the key is to try and determine how I can write this as a sum or difference, or as a double angle, like half of the angle. Do we have a pi over 24 on here? No. When we get to the half angle formulas, which I think we're going to get to, actually, I don't know if we do it in this course or not, but double this is pi over 6, so we could maybe, right? If we double this, it's pi over 6. So, but I don't think we have that identity. We haven't done that identity. Okay, so this is the way you have to do it. You have to do it as a difference. So, all that to say, we're going to remember we have to do the reciprocal of this later. We can't forget that. 1 over, right? But this is going to be actually sine of pi over 3 minus pi over 4. Okay, does everyone see that first step there? All right, so let's rewrite this then. So sine of difference. So what is that again? Someone shout that out. What's the, was it sine of A minus B is?
Sine A cos.
Now is sine, is sine, sine, cos, cos? Or is it sine, cos, sine, cos? Remember, that's what you want to remember. Okay, so it's sine, cos, right? Okay, so let's just start there. Sine of, we'll just pick the first one, there's A. So sine, cos, and this is multiplying. Now is it plus or minus? Is it the same or different? Same or different? What does it say?
Minus, the same.
It's the same? Okay, yeah, we can go back and check, but everyone agree? Anyone seeing that? No? Some of you have your books right open there. Yeah, we're good? So sine, cos, and you can do, now we have to just flip the numbers, right? So you can do sine here, but you got to do the other number. Cos pi over 3. That looking good so far? Mm-hmm. Okay, so the exact value is coming up here. Now we can look on the unit circle and we just find all these values and we do some evaluation. So exact value, we would not do a decimal. Sorry, I'm trying to get this stuff out of the road here. Come on. Okay, and again, we do have to do 1 over, so however you want to just remember that, please don't forget, we're doing 1 over. So sine of pi over 3 is what? Root 3 over 2? Okay. Times cos of pi over 4, root 2 over 2. Minus root 2 over 2 is sine of pi over 4. Cos of pi over 3 is 1/2. And we're doing 1 over. So we multiply this together, what do we get? Root 6 over 4 minus root 2 over 4. Okay. So this is going to be root 6 minus root 2 all over 4. Can you combine root 6 and root 2 and write that as maybe root 4? Can you do that? No, you can't. So they're not like terms. So they're different values, so you can't combine them to 1. But now we're doing reciprocal, right? Remember, 1 over, 1 over. So does it make sense to do this?
Yes.
1 over this reciprocal, just flip and then multiply. So this times 1. Can't simplify any of these. I think this should be good. Is that the answer you got in the back of the book?
No, you can't continue to simplify.
Well, you can take a root 2 out. Do they take a root 2 out there?
It's the simplified extra.
So with the radicals in the denominator, you can leave it like this, but you could factor a root 2 out of there. Do they rationalize the denominator?
They rationalize
Okay.
the denominator.
Okay. So that's version A. Technically, and again, this is going to change when you get to calculus and AP calculus, but right now, radicals in the denominator are technically not simplified. So if you get to this point, then you're mostly right. Do you guys know about rationalizing the denominators by multiplying by conjugates? Do you guys remember that? Some of you are shaking your head, some of you are nodding your head, some of you are literally nodding off. Okay, everybody wake up. So to rationalize by, when you have 2 radicals, you multiply by the conjugate. So that's the same terms but opposite sign. And then that'll turn into a difference of squares, remember that? What you do to the bottom, you have to do to the top. So then this becomes 4 root 6. I mean, I guess you could write that as a factored. That's always good, I guess. And then this one becomes the first term squared, which is 6 minus the last term squared when you do FOIL. So 6 minus 2. So then you have 6 minus 2 is 4, divides with that factor of 4. So you just have root 6 plus root 2. Oops. Now, is that what the back of the book says there?
And then take the root 2 out.
And then they factor it again. Okay, yeah, sure, you factor it again, fine. It's all good. How do you factor this? Well, root 2 is a common factor, actually, because root 6 is actually root 3 times root 2, right? So root 2 is a factor. You have root 3 plus 1. That's where they settle?
Yes.
Okay. So if you got to any one of these 3 stages and then you're like, oh no, I'm wrong, the back of the book. Okay, if you got to there, mostly right. If you get to here, even closer to being mostly right. And then this would be no radicals in the denominator and fully factored. Okay? If you have no radicals in the denominator and you've got everything expressed as factored, then that's simplified, rock bottom simplified. You're good. Okay?